Okay, right. So, and we see, yeah, we're still sketching curves with asymptotes. We looked at two types. I can't remember which one was which, but we had the linear function of x and divided by linear, and then I think we had the quadratic divided by linear, or the other way around. Yeah, linear divided by quadratic. So today we're going to look at the first one, type 3, quadratic divided by quadratic, which won't take us too long. And then the quadratic divided by linear, that's a whole different thing that will take us a bit longer. So this is a quadratic divided by quadratic, okay? Quadratic in x. And what we're trying to do is eventually sketch it. Now, I'm not going to sketch the whole thing because we're just going to do the new bits. The non-new bits I'm not going to do. So we need to, first of all, find out, let's look at the horizontal asymptote. Horizontal asymptote is basically the value of f, or we call it y, when x is approaching infinity. Yeah, it's where that graph, where it approaches, if it approaches, sometimes it won't. Okay, and while I was chatting to you on is the way to do it. Okay, so what we're trying to find out to get the horizontal asymptote, okay. The way to do it is basically to take the limit of f of x when x approaches infinity. So in this case, the limit, okay, I'm going to just write it. Okay, yeah, limit x approaches infinity. In this case, 2x squared minus 5x plus 2 divided by x squared plus 3x plus 2. And then the trick that we learned last year, and I reminded you in the last lesson, is that you look at the highest power of x and you divide the top and the bottom by the same amount. So in this case, it's x. What are we going to divide by? X squared. X squared. Top and the bottom. As long as I do it to the top and the bottom, then I can do it. Right? If I divide the numerator and denominator the same number, no problem. So what I will get is limit x approaches infinity. 2x squared divided by x squared is 2 minus 5 over x plus 2 over x squared divided by 1 plus 3 over x plus 2 over x squared. Everything divided by x squared. Now at this point, now I can substitute x is infinity. Okay? Because why couldn't I do it here? Because I had a whole bunch of infinities divided by infinities, infinity squared plus infinities. How do I do it? Now by getting rid of this x squared, okay, this term will be 0, this term will be 0, this term will be 0, this term will be all 0, and the only thing I'm left with is 2 over 1, which is 2. Okay, so the horizontal asymptote is simply, well, let's not draw a straight a solid line, it's this, okay, y equal 2. Okay, right, let me just make some space. So how do we find, that's the horizontal asymptote. That's what the f approaches when x approaches infinity. What about vertical asymptotes? So Arnes, you said correctly, the vertical asymptotes is where the denominator is 0. Okay, in my language, the way I say it is where the f blows up to infinity. Because when this is 0, then the f goes up to infinity or minus infinity. Okay, so we basically need to solve. Okay, I'll write it down here. It's when the denominator equals 0. There's an equation that we have to solve. Okay, so x squared plus 3x plus 2 equals 0. Okay, and yeah, yes. And we just solve that. X plus 2, x plus 1 equals 0. We can see there's two asymptotes, isn't it? There's one at x equal minus 2 and one at x equal minus 1. So I'm going to draw them here. Minus 1, I'll write them like this here. X equal minus 1, x equal minus 2. And I think it's always a good idea to write them so the examiner knows for sure you labeled all your asymptotes. Okay, now at this point I'm actually going to leave this exercise. Obviously we haven't finished, but the rest is just like we did last lesson. Okay, you need to find I would find the x-intercept, the y-intercept, the stationary point, figure out what is that going to look like. Is it going to look like this, that? Nothing is different to what we did last lesson. Okay? Right, I'll just pause here. Right, so for an interesting discussion that I just had with Arne here. And actually what I'm going to do now, I'm not going to go show how you solve this problem, but I'm going to just draw it, okay? So it turns out that there's a graph here, then there's the graph here, and then it goes like here. Okay? That's apparently the solution. And you can go and follow the book and, you know, but I haven't done it, I'm just showing you the result. Why am I showing you the result? Because Arne realized that there is something very different between the horizontal asymptote and the vertical asymptote. Okay? The vertical asymptote, the graph they can't touch it. They definitely can't cross it. Why can't they actually touch it or cross it? Yeah, well, it's not the real, it's undefined. It's different. It's not that infinity is a real, I don't know if it's a real number, but it's definitely, it's in the real domain, but it's undefined. Okay? This function is not defined for x equal minus 1 and x equal minus 1. So it definitely cannot cross it. With the horizontal asymptote, you can see it actually does cross it here. Okay? What is a horizontal asymptote? Is basically the value of f when x is equal infinity. Sometimes it will be minus, or it is actually also minus infinity. So when you go infinity and minus infinity, it will get closer and closer to y equal to. Okay, that's a very good observation. Okay, we'll move on to the next problem. Okay, so the fourth and last type is a quadratic in x divided by a linear in x. And it's always the last one is always the problematic one. It's harder, but also more interesting. So, I mean, let's start by, you know, I'll put this axis here. Let's see what the easy bit. So, what will be the vertical asymptote? I can really straight away see. Okay, vertical asymptote. Okay, remember what's vertical asymptote? Well, it's undefined. X equal 1. Okay, so very easily you can see 1 is going to be the vertical asymptote. Okay, cool. Horizontal asymptote. Let's just think about that. I'm going to pause, talk to you. Okay, so what is, you know, if I'm looking for horizontal asymptotes, it's basically, as we said, what happens when x approaches infinity. So I've got, naively, I can write it down as infinity squared minus infinity minus 6 divided by infinity minus 1. Okay? You can kind of see, as Arne said, that it's the top is going to beat the bottom. Okay? If I do it a bit more formally, I can just divide both sides by x squared. We always divide by the highest one. So it's going to be 1 minus 1 over x minus 6 over x squared divided by 1 over x minus 1 over x squared. We're obviously looking at the limit where x approaches infinity. Okay? And we're going to have all these things become 0, 1 over 0. So it's infinity. So in other words, as x approaches infinity, f goes to infinity. And you might think at this point, maybe just leave it. There's horizontal, there is one vertical and there's no horizontal. But it turns, there's this thing, and I can say it, but I don't know how to write it, oblique asymptotes. Okay? I'm going to write it down here. Oblique. I think you write it like this. Is that, yeah? Okay? Let's see what it is. I'll just clear some space. Okay. So to try and find out what is this oblique asymptote, okay? I'm going to get rid of that. What we have to do, we have to actually divide these polynomials. Now, my weapon of choice when we divide polynomial, I use by inspection, and I've shown you that once or twice, I think. But the other way is long division. So I think we'll do long division. Arne will just help me here because it's not my favorite. Okay, but we'll just do it. Okay, so we write like this, x minus 1, right? Okay, so now I'm going to think about what am I going to multiply this x minus 1, so I will get x squared and then get rid of it. Okay, let's do it in blue. So obviously I'm going to multiply it by x. So the x times x is x squared, but we also have minus x. This is quite an easy one. Okay, now the next bit I need to do, I'm going to minus these two terms. So I'm going to have, this is 0, so that's sorted. This is 0 as well. So it's pretty much easy. Okay, it's going to be 2 easy. Okay? And then I've got, yeah, the minus 6. I'm going to move the minus 6. Now the minus 6, I can't multiply x minus 1 to get rid of a minus 6. So it's remainder. Okay? So I've got a remainder of 6. This is the remainder. So what I can write down that x squared minus, I'll write it down here. It's the same, x, if I divide x, this polynomial by x minus 1, I'm going to get x minus 6 over x minus 1. I'm just going to check that I didn't make a mistake. Okay, if you are a little bit confused like I am, just bear with me because I'm going to do the same thing by inspection. I find it a little bit easier. So, again, what am I trying to do? I'm dividing this polynomial by this polynomial. The answer will be a polynomial. Okay? But there might be a remainder. Just like if I do, let's say, 63 divided by 5. How do you write it? By 5 like this, or do we write the 5 on the other side like this? I can't remember. I think I normally wrote like this, but maybe it's because I'm coming from a place where they drive on the right. Maybe I don't know. But here, how do I do that? I do 1 times 5 equal 5, and then I get 13. So 2 times 5 is 10. I still have 3. So the answer is 12 and 3 over 5. Yeah? So that's the same thing here. What's the answer? Well, the answer is x. But I also have a remainder. And the remainder I need to divide by this denominator. Right, let's try and do the same thing, but now with the way I would do it, by inspection. This is long division, now inspection. Right, long division, now inspection. If I try and find out what this thing is, okay, I'm going to circle it, let's pretend we don't know what it is. I'm going to write it down like this. X squared minus x minus 6 is going to be equal to x minus 1 times that polynomial, okay? So this one now, I don't want to erase it because we will compare it later. Let's say I don't know what it is. Well, that thing is basically a polynomial, isn't it? Okay? Maybe with a remainder. Maybe with a remainder, okay? So what is it going to be? I don't know. But I can guess what will be, first of all, what will be the degree. Yeah. What will be the degree of this polynomial? Okay. It has to be linear in x. Why? Because if I time it by this, I get a quadratic. So there definitely needs to be an x there, but not x squared. There can't be an x squared. Okay? So I'll put an x. Now, maybe I should ask myself, what should be the coefficient in front of x? 1. Well, it has to be 1 because x times x is x squared. That's called inspection. We're checking it out. Okay? Now, actually, this is really, now we need to check out what will I get as we got x squared, that's fine. What about the x? Okay, so if I multiply that by that, I will get minus x, so that's great. And that's it. I'm not going to have anything else there. Can I have something else there? I can't, because if I put something, let's say, I don't know what, you might think I should get 6 plus 6. 6 times minus 1, right? Will give you minus 6, but then I'm stuck. Why am I stuck? Because now I'm going to have a 6x, and I don't want the 6x. I've got the minus x that's sorted. So I got to stop here. And the remainder will be minus 6. Right? Check this out. X times x is x squared. X times minus 1 minus x. And I've got minus 6. So that's it. I'll just pause here. Okay. Right. So we use inspection to find how can I write this polynomial. And if you don't mind, I'm just going to write. I don't need these brackets. There's no point in having that bracket. So I'll just put that time x, and I'll bring the minus 6. Don't be scared. He doesn't have COVID. Can get it closer. Here we go. Okay. Now I can, when I write it like this, it might take a little bit longer, but then you can easily find out what can go from here to here, because I think to go from here to here using that, it's like you don't know what to do with that remainder. Okay? You're right. You want to just, okay. So what we're going to write now, we're going to rewrite, I'm going to divide both sides by x minus 1. And then I'll say, okay, x squared minus x minus 6 divided by x minus 1 simply equal to x minus 6 over x minus 1. So that's what I was looking for. I think by inspection, to me, this is a little bit easier. And obviously, we're getting the same. Okay, so I'll pause here, make some more space. Right, now the question is, why did I do that for? Why did I write this as that? Well, the one thing is obvious here is that also I can see that vertical asymptote. So I didn't lose that information, but actually I gained another information. And the information is that thing that I already raised, which is the oblique asymptote. Because what was the horizontal asymptote? We were looking what happens when x approaches infinity. Okay? Now let's think about these two terms. Okay? I'm going to rewrite them again. F of x is equal to x minus 6, x minus 1. Okay? When x approaches infinity, have a look here with me. I need you for this. Okay? When x approaches infinity, which term is more powerful? Okay? There's two terms.
Yeah.
Let me ask you this question. What happens to this term when x is infinity? It becomes naught, because infinity minus 1, let's write it down, okay? Let's write it down. Limit x approaches infinity. Let's just write that. It's going to be infinity minus 6 divided by infinity minus 1. Obviously, that is going to be 0, so it's infinity. But, okay, I already knew that goes to infinity. But now what I'm getting is that as x gets bigger and bigger, this becomes less and less important. It contributes less. Do 6 divided by 10 million minus 1 is 0, 0. Okay? So which term is more important when x is bigger? The first one, okay? This term, more significant when x is large. But now this term, I know what it looks like. What is x? F of x equal x. How would you describe it to a grade 9 student? Straight line going through? Through where? Where does it go through? The origin?
Yeah.
What angle?
It's a
45 degrees. So we've got an oblique asymptote. When x approaches infinity, it will get closer and closer to f of equal x. Okay? The value of f of x will be infinity. But I know more than that.
It's also increasing. It's not.
Yeah, it's just that line, I don't know where that line, we're going to have to try and figure out. It might go like this, it might go like that, it might go like this, and on the other side it will go like this or like that. But I know that as, I'm just opening your mind a bit, other than horizontal asymptote, vertical asymptote, I can also have diagonal asymptotes. That's what the oblique asymptote is, like a diagonal one. Okay, I still don't know which one it is. We need to get some more information. Okay, but I've written the oblique asymptote y equal x. That's oblique asymptote. Okay?
Is it going to be like that for all quadratic linear?
Exactly. All quadratic linear, I think, the one that I can think of will always have some kind of oblique.
So it might be like y equals x plus c.
Yes, yeah. So this one is going through origin, but I might have often they will be shifted. Okay? Maybe we can think about another example later. But what I want to do is solve this question completely. In other words, sketch the graph. And when we have time, hopefully, I'll show you just other kind of asymptotes. But we're not going to go through all of it. Right. Now, let's find intercepts. Okay? So intercepts are where, let's find when the x equals 0. Okay? When x equals 0, now I'm doing intercepts. X equals 0, I'll just put quickly in that, I'm getting minus 6 over minus 1. Just please check me. But yeah, and that's obviously 6. Okay, so I've got that point 0, 6. Okay, sorry, was that x intercept? That's y intercept. Okay, there's a 0, 6 here. Okay. X intercepts is when y is equal to 0. Okay? Okay, so I'm going to write x squared minus x minus 6 over x minus 1 equal to 0. Okay, I can obviously ignore the denominator. For this whole thing to be 0, I need the top to be 0. So I need to basically solve this issue. Okay, that must be equal to 0. So x minus 3x plus 2 equal to 0. So I've got two x-intercept. Okay, I'll write them down. I've got 3, 0 and minus 2, 0. So I've got 3. This is 1, 2 for the 3. There's a point here. And the minus 2. Minus 1, minus 2. There's another point here. Okay, so I've managed to get 3 points. Okay, I'll just pause here, make some space. Okay, so we've got all the asymptotes, we've got all the intercepts. Maybe I'll draw them in blue. They'll stick out a little bit more. The next thing is stationary points. How do we find stationary point? First derivative is 0. Now, here's an interesting thing. We have two expressions for that function. It's the same thing. Which one do you reckon should we use? I mean, we can use either one actually. Either one. The easier one. They're both, I mean, here we have two terms, so we just need to do the derivative of each one. I personally would choose that one, but actually this one is really easy as well. And anyway, let's use that one. Now, do you know what? This will be easy.
Use that one because you only have to do one quotient rule and not a quotient rule and a...
Yes, and the other thing is you're only looking at the numerator anyway, because you want to make it equal to 0. Where here it will have to factorize something. Okay, so we're going to find the derivative of this one, which is 2x minus, I'm calculating the derivative, okay? So it's 2x minus 1 times x minus 1, I did a derivative of that times that, minus, okay, I'm going to erase this, hopefully you'll remember those points, okay? Minus the derivative of that, which is just 1, times this whole mess, x squared minus x minus 6, divided by this square, right? X minus 1 squared. Okay, let's tidy it up a bit. 2x squared minus 2x minus x plus 1 minus x squared plus x plus 6. Please check it if you don't mind, because it would be terrible to make a mistake here. The derivative is going to be x squared minus 2x, I think, plus 6 divided by x minus 1 squared. Let me just check that I've got it right. Okay, so we try, obviously, to get a stationary point, the derivative, the first derivative must be equal to 0. So we are trying to solve this equation. We're trying to find out for which x this thing is 0. And Olivia already put it in her calculator, ax squared plus bx plus c, and she found that the answers were imaginary. In other words, there is no real number that solves this. Now, we can try and think about why that happens. What kind of graph? This is a parabola. Okay? What kind of graph is it? Happy or smiley face or sad face? Okay? Because before the x squared, it's positive, so it's a smiley face. So it's going to be something like that. I don't know where it crosses, but it's a smiley face, and it doesn't cross. It doesn't have a y-intercept. Now, why do I need to know it's a smiley face? Because if it's a smiley face, that means it's always positive. In other words, the first derivative is always positive, so it's important. This first derivative is always positive. So it turns out there is no answer to that, no solution. F prime, the first derivative, is always larger than 0. And we're going to need that information. I'm going to write it down here. The first derivative is always positive, meaning, what does it tell you about f? The first derivative is always positive. F is always forever increasing, forever increasing.
So it won't have a stationary point.
It won't have a stationary point. Now, I want to show you this in another way that they used. I think it's something that we can learn from. So, unfortunately for us, we decided to do the derivative of this expression. What they did in the book, they did the derivative of that. Remember, we had the debate which one to do. And if we did that, the answer would be a bit more obvious. Because what's the derivative of this? Okay, well it's 1, x is 1, minus, okay? Let's rewrite this a little slightly different. X minus 6 times x minus 1 power minus 1. You know, we always write these powers, negative powers. So the first x becomes 1. This is going to be minus 6 times x minus 1 to the power of minus 2. That it goes down. Then we need to time it by minus 1. That minus 1. And then the derivative of the inner function, which is nothing, is 1. Okay? So I'm not going to even write it. So let's write it again. It's f derivative is 1 minus 6, or actually minus 1 times minus 1 is plus 6 over x minus 1 squared. Okay? Now, let's try and think. I mean, because what we were trying to find out was, when is the first derivative equal to 0? If we think about it, it is kind of obvious that this can never be 0. Can you see why? Well, this is a positive, and as you said, this is a positive as well. So the positive plus a positive, it's never going to be 0. And the bonus, if we went this way, is that we don't have to think about smiley face, sad face. This, very obvious for us to see that this number, in fact, there's no solution. It's actually always larger than 0. In other words, this f is constantly increasing. Okay, I'll pause here again. Right. Now I've got the last bit. I've got all information, all the pieces of puzzle. I just need to get it all together. So I know I've got a vertical asymptote here. I can't cross this line. Okay. I also know that I have to go through this point. Let's start from the right. So I have to go through this point, okay? And as I go to infinity, okay, as it gets closer and closer, maybe I'll use a different color. It gets closer and closer to this line here. Now, how do I know I'm going to be on this line? Because I come from the bottom. I know I've got a point here. Before I had that point, I would have come closer from this side. But now I know I've got a point here. So it must go through there. Now, what will I do when I go down from here? I must get close to what? To this vertical asymptote. So like this. Okay? Shouldn't have that wobble, but you can see it. Okay? So I'm going between these two asymptotes. Okay? Now, what about here? Okay? From here, which way should I be going? Okay, well, I'm heading towards my vertical asymptotes. So I should be going like this.
Yeah, and then from this side.
And then from this side, I'll go here. Hang on, I didn't draw it. Yeah, okay, yeah. Okay, yeah. So it will go like this. And then closer and closer. I didn't really draw it really well. I should have put it a little bit. Let's see if I can push them a little bit to the right. And it will look a little bit better. Okay, so I'm going to have, no, I don't want to raise. Okay, so I'm going to go like this, closer and closer, closer and closer and closer and closer to that diagonal asymptote, oblique. Okay, again, not the best one. Yeah. I think that's it. Okay, right, I'll pause here. Okay, so that was an example from beginning to end. Now I'll do one, maybe two examples, but I'm not going to sketch them. All I want to do is write them in a way that we will be able to see the asymptotes. Already we can see the vertical asymptote at x equal 2. Okay? But to find the oblique, we know it's a quadratic divided by a linear. There must be these oblique asymptote. We actually need to do the division. Either you do long division or you do inspection. So for now, we decided we're going to try long division. Okay? We don't have our mate to help us here, but we're going to do our best. Okay? So we're going to divide that by that. Okay. What should we multiply x by? So we will get x squared. X. Okay? So x times x is x squared minus 2x. Because I also multiplied x by minus 2. So here already we're getting slightly different. That's quite good. So now I'm going to minus these together. I'm going to get 0. minus x minus minus x is plus x. Okay, I've done that because I'm doing that minus that. Got rid of the x
And
squared.
you bring down the 1.
Okay, I'll wait with that one. I'll wait with that one. Okay, now I'm going to say, okay, what must I time this by to get rid of that x? So x plus just 1, right?
Yeah.
Yeah. So 1 times x will be x, and minus 2x, minus 2. And then you're right. Now I'm going to add that one. I guess I could have done it before, isn't it? Okay. So now I'm going to minus these together. I'm going to get 0 plus 3. Okay. I'll just pause here to make sure that I've got it right. All right. So yeah, we got it. We got x plus 1. Now I've got a 3. Now if I multiply, if I decide that I want to go with something else, whatever I multiply x by, I'm never going to get rid of this 3. Okay? Yeah, that's the remainder. That's the remainder. So now the next obstacle is to be able, how to write that? How can I write this?
So x plus 1.
X plus 1 plus
3 over x minus 2.
Okay, no, you're very happy with that. Okay. So that was my my mission really, to find that out. Now let's just try again. I'm not going to draw the whole graph, but at least if I can sketch the asymptote. Okay. So one asymptote we already figured out is x equal to. Okay. What will be the oblique asymptote? Okay. The oblique asymptote is, you got to ask yourself. I know I've got 3 terms, but I can call them. I call them 2. I've got this term, the one with the something in the denominator, and the other one. Okay. I've got something in the denominator, and I've got some kind of linear fraction of x, and that's always going to be the case. Before we had x, now we have x plus 1. Sometimes we want to have 2x minus 1, but it's always going to be a linear function. Okay. So as x approaches to infinity, when x approaches to infinity, okay, this guy dies. It always becomes 0. So what we're left with is x plus 1. Okay? So at n infinity, I'm going to have x plus 1. What does x plus 1 look like? It's plus 1. So I shifted it up 1. Okay? So we're going to have, like, let's say this is minus 1. So I'm going to have something like this. Okay? So I didn't draw the graph, but I know at infinity is going to approach, going to go here. At minus infinity is going to go there. I don't know from which side, but yeah, that's it. Okay. Right. I'll see if there's anything else, but I think this is kind of clear. Okay? Great.